Hi guys, my name is Mosh Hamadani, and in this video I'm going to talk about C# generics. Before we start with generics, let me explain what problem generics came to solve. In .NET version 1, we didn't have generics. So let's say we wanted to create a list to store a list of numbers. This is a simple and basic implementation of a list. We could have a method called add to add a number to the list, and an indexer that returns the number at the given index. Now, of course, there are more methods like remove and find, and I'm just leaving that for simplicity here because the intention is to talk about generics and not data structures. Now, if you wanted to store books in a list, obviously this class wouldn't work. So we had to go and create a class like this. Call it book list with a method called add, a parameter called book, and similar indexer. Now the problem here is for every type we have to create a separate list. And this is a lot of code duplication and not productive. Plus, if there is a bug, we have to fix it in multiple places. So one solution to fix this is to use a list of objects, something like this. With the object, because the object is the parent class for every type in .NET, we can easily pass any types to this method here or get any object from this indexer. But there is another problem here. The problem is performance. If we use this class for storing value types like integers, every time we insert a value type inside this list, it has to be boxed to be stored as an object. And every time we access that value, it has to be unboxed. And this has a performance penalty. Or even if we use reference types, every time we want to cast an object, let's say a book, to an object or vice versa, this casting again has performance penalty. So generics came as a solution to resolve this problem. With generics, we create a class once and reuse it multiple times. And it doesn't have the performance penalty like with the object list here. So let's see how we can create a generic list. Let me get rid of this code here. So I'm going to create my generic list next to this one so you can see the differences. We start with public class. I call it generic list. Now, generics have a parameter, and the parameters are specified with angle brackets. So like this. And we usually call them T, as in short for template or type. Now we create our add method. Now, instead of getting a book here, we would get a T. What is T? We don't know yet. The consumer of this class will specify that. I will show you in a second. Similarly, to get the object at the given index, we return T. So that's all we have to do. Now let's see how we can use that. We go to our program CS. So here, we're instantiating a book object. We're instantiating a list of numbers, as you see, and we're instantiating a list of books. Note that the problem here is that we have two different types of lists. We can simply use our generic list instead of these two classes here. So I can actually comment out this piece of code. Now let's create a list of numbers. I use the generic list. And here I specify the type of T that we specified earlier. So in this case, we want a list of integers. So I'll put int here. And now when I access the add method, note that the parameter is of type integer. We can use the same generic list to store a list of books. So I specify book as the template parameter. And say books.add. Now the add method gets an object of type book. So new book, blah, blah, blah. So see, we get code reusability and we don't have that performance penalty. Why? At runtime, our generic list is actually a list of books. It's not a list of objects. So there is no casting or boxing. So this is the basics of creating a generic list. Now, in practical terms, most often you will be using generics as opposed to creating ones. In fact, I personally, in my professional career as a .NET developer, have very rarely come across situations that I had to create generic classes or generic methods. I would say maybe 3 or 4 times over the course of a few years. Most often, you will be using the generic lists that are actually part of .NET. So you're not going to create a generic list. In fact, let me show you where all the generic collections are in .NET. So you go to system.collections.generic, and look, here we've got a bunch of classes like dictionary, HashSet, some interfaces like iCollection, iDictionary, iEnumerable, which is pretty popular, iList, linked list, list, which is like our generic list, queue, sorted list, stack, and so on. But in case you need to create a generic for the application you're working on, the rest of this video I'm going to cover more details about creating generics. So let's get back to our generic here. See, here T is a parameter. We could have multiple parameters. For example, a use case of that is for dictionaries. A dictionary is a data structure that uses a hash table to store and retrieve objects, which provides a very fast and efficient way to access objects. So with a dictionary, we need to specify a key and a value, and they can be of any type. So let me create a dictionary here. Public class generic dictionary. So I want a key here and a value. Note that I'm prefixing them with T and giving a proper name here, like this is the template parameter for key and this is the template parameter for value. I have seen some developers use something like T, U, or V here, which actually makes no sense in terms of code readability. So always prefix your generic parameters with T and then give it a proper name. So in this case, our dictionary has 2 parameters, T key and T value. Our add method would look something like this. T key, key, T value, value. Now, to use that, we can go back to our program CS. Let me create a dictionary here. Generic dictionary. I want my keys to be of type, say, string, and values can be of type book. This way, I can call the add method, and note that the first parameter is a string, and the second is a book. So I can say 1, 2, 3, 4, and I'm going to store this book here. Just like that. Another thing you need to know about generics is constraints. Look, in this case, our generic list here, or generic dictionary, any type can be passed here. There's no limitation. Sometimes this is good, like in terms of list, we probably want to store a list of anything and everything, so there is no need to apply constraint. But sometimes you would want to limit what is being sent here. Let me walk you through some examples. So back to our program CS here. And we use ReSharper to put it in a separate file. Okay. Let's say we would like to create a method that gets 2 parameters, let's say 2 numbers, and returns the bigger one. So typically, this is how we do it. So if A is bigger than B, we return A, otherwise we return B. Now, if you want to create a generic version of that, this is how we do it. So public, instead of returning int, we return T, and the name of the method. Here we add the template parameter. And of course, both of our parameters are going to be of type T. So TA and TB. Now, see, if I write the exact same code, it's not going to work. Why? Because at this time, the compiler doesn't know the type of T. So it cannot apply comparison between A and B. At this point, it thinks A and B are both objects. Let me show you that. So these are the methods that are available in A, which come from the object class. So what we need to do here is we want to assume that both A and B implement a comparable interface, which provides a method called compareTo. And with that, we can compare these two objects. So that's a use case where we need to apply a constraint. We apply a constraint by going here at the end of the method and saying where t, we use colon, as in is I comparable. With that, if I say a dot, see, we get a new method here, compareTo, which comes from a comparable. So with that, we can say if A compareTo B is greater than 0, return A, otherwise return B. Also note that here I created a generic method inside a non-generic class, and that's perfectly fine. So you don't always have to start with the generic class. You could potentially move this template here to the class level. So utilities for T, where T is IComparable. And then we don't have to repeat that here. We can just get rid of that. Just like that. Okay, now that you have an understanding of constraints and why we need them, let me show you the other types of constraints. Here are 5 types of constraints. You can say where T is IComparable, as in applying a constraint to an interface, or you can apply a constraint to a class. In this case, we are saying if T is a product or any of its children, any of its subclasses, you can say T should be a value type. So we use the keyword struct. Or you could say where T is a class, as in it has to be a reference type. Or you can say where T is an object that has a default constructor. Now, don't worry, I'm going to walk you through these with examples. So far you have seen a constraint to an interface. Let's take a look at a constraint to a class. So I create a new class here, public class, say discount calculator T product, where T product is a product. Now I'm going to move this to a separate file. So in that case, I can create a method here. Let's call it calculate discount, which gets a parameter of type product or any of its subclasses. And here, look, we get the price and title attribute or property. Earlier, I created this product class. Let me show you. So this is my product class. We have a title and a price. We also have a book class here that derives from the product and adds an extra property here called ISBN. So with that constraint, when we say T product should be a product or any of its subclasses, we have access to all of its properties or methods here. Now, we don't really care about the actual calculation of the discount, but you got the point. Let's see an example of a constraint to a value type. So a public class nullable T, where T is a value type. Let me move that to a separate file. Okay, what is this used for? Well, in C#, as you know, value types cannot be null. So an integer should have a value like 0, 1, 2, 3. It cannot be null. We can use this class to give our value types the ability to be nullable. So let's create a constructor here. Let's say in the constructor we can get a value, and in this class I'm going to store it as an object because I want it to be nullable. So private object value, and here let me initialize it with ReSharper. We can press Alt and enter here and enter, and it automatically initializes my private field with the value passed in the constructor. Now I want this class to have a property called hasValue. So if my object has a value, it returns true. Otherwise, if it's null, it returns false. Get return. So if value is not null, return true. And we can have a method called public, which returns t, get value or default. So with this method, if our object is initialized, let's say we have a number that is set to 5, it returns the value, which is 5. Otherwise, it returns the default value for that type. So for integers, it's 0. So what we need to do is we say if it has value, then return value. Now we just have to cast it because this value here is of type object, right? But this cast is perfectly fine and it's safe because that's what we are passing here in the constructor. We're storing it here. It's basically being boxed to be stored in the object, but here we are unboxing it and that's perfectly fine. Now, what if it's not set? What if it's null? We need to find the default value for that type. How do we do that? We use the default operator. So we say return default of t. So default is a good keyword that you need to know. Now with this class, what we can do is we can go ahead and actually, I forgot to create a default constructor here in case the value is not set. Now let's go to our program CS and use that. I'm going to clear everything here. We don't need them anymore. So I can say for number equals new nullable of int, I can give it a value like 5. Let's log something to console. So CW, it's a code snippet. Press tab. I would say hasValue plus number that has value, console write line, and the actual value is plus number that get value or default. Let's run this code. So note that, yes, it has a value and its value is set to 5. Now we can use this class without setting a value. In this case, we have a nullable integer. So let's run this again. So it has a value? No. What is the default value? It's 0. Now, you don't really have to go and create this nullable class. It's actually part of .NET Framework. You can find it in system.nullable. It's defined here. And in fact, it's a structure. Look at this icon here. It's not a class. So let's go here. So this nullable is using a constraint to specify that t has to be a value type. Let's look at another example. Let's go to our utilities class here. Let me create another method here. Public void do something with t. Now let's say in some specific scenarios we want to instantiate an instance of t. So if you want to create an object, you want to do something like that. But that doesn't work because at this time, the compiler doesn't know exactly what type t is referring to. All it knows is that t should implement a comparable interface. If you want to instantiate t here, you need a default constructor, right? So what you can do is to apply a second constraint here. You can separate constraints with a comma. So to have a constraint to a default constructor, that's what you use. New. Now this is perfectly fine. So with constraints, we can specify that t must implement a given interface or be of a given type or any of its subclasses, or be a value type or a reference type, or have a default constructor. I hope you enjoyed this video and thank you for watching.